Welcome to this episode of the Verilog Bench. Today we're going to be looking at the latest APB family issue from the RTL and verification perspective. The useful questions here are stable timing windows, waits, error completion, and what optional signals mean for real logic. The first implementation point is that the state machine is still extremely small. You move from idle to one setup cycle, then into access, and you stay there only until completion. For a write, the implementation burden is mostly about stable information. Once the transfer enters access, the request information and any configured sidebands must remain stable until completion. Reads are the same timing shell with one important obligation on the completer. Read data has to be valid for the cycle that actually completes the access. Wait handling and error handling are narrow but important. The access simply waits in place until ready, and the error result only matters in the cycle that actually finishes the transfer. The latest issue can look bigger than the logic really is. Most of that extra size comes from optional signals that only matter when the design configuration includes them. Wake up is a good example of how issue E grows around the core. The system can establish low power context first, and the actual APB transfer still stays as simple as before. The implementation takeaway is that APB issue E is still a small bus if you keep the configured interface explicit. Most bugs come from violating stable timing or from mismatched assumptions about optional signals. If this APB RTL deep dive was useful, like and subscribe to be notified of future videos. Next, we stay on issue E and translate the bus in a software visible platform behavior. Before that, here's the glossary. APB means Advanced Peripheral Bus. P-Ready holds or completes an access. PSLVERR is the peripheral error signal sampled in the completing cycle, and PSTRB marks valid byte lanes. PPROT is the protection attribute signal group for an access. PWakeUp is a wake-up-related sideband signal. Requester is the interface that starts the APB access, and completer is the interface that finishes it.